All right, so we're moving on to a new unit. The test for this unit is going to be right when we return from fall break. Huh? Yeah, next week. Next week. Yeah, next week. So that was cute. So we'll talk about that as it gets closer. The unit is gonna involve volume. Okay, so before you left, I mean, it was just more to give you an easy grade than anything. But I introduced. You okay, Sam? Just having a seizure. Oh. We introduced three-dimensional solids, and we were showing you how when you get a two-dimensional polygon or the shape and you wrap it around an axis of rotation, that could create a three-dimensional solid, and it was just meant to play around. As long as you participated in it, I gave you credit, like those grades are in the grade book, along with the test grades. The homework grades, which not many people did, and I gave you another day on Friday just to work on that. I'm sorry? You don't like the Google Docs? Mhm. Mhm. All right. So what Mohammed is bringing up is saying that, Khan Academy and Delta Math are more interactive, meaning like if you get it wrong, they would give you some hints and some feedback. And I can't disagree with that. But what I can say to that is, how long do I give you to work on these assignments? A week. They're weekly assignments. You have a week to work on it. In many instances, I know I wasn't here on Friday, but in many instances, I'm giving you class time, like when I'm here to work on it. I tell people, hey, share your screen. I also pride myself on being able to give timely feedback. So let's say you would have worked on this throughout the entire week or started it early, and you would have been confused with something. You would have either A, had time in class to, hey, Mr. Romero, I'm stuck on this one, can you help me out? Or B, just send me a screenshot on Remind and say, hey, I'm stuck on this. I mean, I help people like that all the time. So does it have, is it less interactive? Sure. But is it impossible? No. Yeah. So, okay. Any other questions, whether at home or anything like that, on anything from the past before we move on? I sent out progress reports again last week. So it's still, it's still early. We still have 4 tests left. It's still early, but if you're like in the 50s and 60s, sorry, it's still very reasonable to think that you have time to pick it up. If you're in the 20s and 30s, I'd start to worry now. If something doesn't change dramatically, then that's where you're gonna stay. All right, so today and tomorrow we're working on the volume of prisms and cylinders. Okay, and what both of these have in common is that they have 2 bases. The base is actually where it gets the name. So like we have rectangular prisms, triangular prisms. So that adjective that comes in front, that's due to the shape of the base, whatever the base is. So like for instance here, like you can see on this picture, there's a pentagonal prism. What is the base of a pentagonal prism? A pentagon. Yeah, I know I wasn't your teacher for first semester geometry, but I'm assuming you've talked about polygons, right? And you know a pentagon has 5 sides. Okay. So now what every prism will have is they will have 2 of those. Okay, we call those the bases. Then another thing that the prism has is that going around it, okay, what we call laterally, the lateral faces will always be, what are those? They're always going to be rectangles. And specifically, it will have as many rectangles as the base has sides. On a solid, we call them edges. Okay, so however many edges the base has, that's how many rectangles you have going around the lateral faces. Okay. Now, this unit would be much more difficult and challenging if they made me teach you surface area, like the surface area formulas tend to be a little bit more complex, I guess you could say, but the AKS just says volume only, so volume tends to be a little bit easier. You know what? The one thing I didn't mention here is a cylinder. So let me go. So, oh, man, here we go. So even though you don't see the name of the base in a cylinder, when they say cylinder, there's still two bases. But what are those bases? Huh? Yeah, they're circles, right? And then you're like, oh yeah, but it doesn't have a rectangle being wrapped around. And this is where, like, if you were here watching in person, you would have this aha moment. What's this that I'm holding up? Yeah, a rectangular sheet of paper. Look what happens when I wrap it around. Yeah, it takes the shape of like a cylinder. So even though we don't call it this, is for the sake of argument, for the sake of comparison. If I wanted to give a cylinder a different name, if I wanted to use the verbiage of a prism because it has a lot of the same properties as prisms, what else could I call it if I wanted to call it? A circular prism. That's exactly right. If we were to use the same verbiage, it's almost the same thing as calling it like a circular prism. Okay. Now, the one thing that all of these cylinders and prisms have in common, besides what we just talked about appearance-wise, is that for the volume of each one can be found by that general formula, where the volume is equal to the capital B stands for the area of that base, and you're going to multiply that times the height of the prism and cylinder. Now, here's where to get confused. That's not to be confused with the height of the base, because all of these bases are going to have a height. Like if you have a triangular prism, that triangle would have a height. If you have a rectangle, you know, that rectangle on the base will have a height. So we're talking about the height of the prism and cylinder. How many bases did we say that prisms and cylinders have? Feel free to answer at home if you know this too. How many bases? 2. So the height of that solid is going to be defined as the distance between those bases. However far one base is away from the other base. That perpendicular distance is the height of the prism. Yes. It's just one of the bases. It's just one of the bases. Now, it's funny. See, the question was, do you have to add the bases up? Now, if you were talking about surface area, which is like the flat space around, a lot of those formulas have you adding the bases because they're both part of the surface. What I would kind of compare this to, I know you guys might be too young for this, but before all this now digital media and stuff and everything became on hard drives and stuff, you know, like when you want to listen to music, what would you listen to music? YouTube? No, before YouTube. Radio. Well, in between radio and YouTube. Yeah, right. It was the CDs, right? It was the CDs. And for a while there, right, when you wanted to get music and stuff, and you would find it digitally, and you would burn a CD, right? So and you can still find them. CDs would come in spindles, right? So if you look at a CD, even though technically there is some type of thickness to a CD, let's pretend that a CD was completely flat. What type of shape would a CD be in? It's in the shape of a circle, right? But they come in spindles. So even though you have a super skinny CD, when you start stacking them and stacking them and stacking them on a spindle, eventually what type of shape does it become? It becomes a cylinder. And that's kind of what we're doing here with the volume. It's just saying, hey, look, let's just get whatever the base is and multiply it by how many bases we like. Not how many bases, because then you're going to say there's 2, but like it's just getting the base and stacking it up and stacking it up and stacking it up and multiplying by, you know, like how many CDs there would be in a spindle, if that makes any sense. The rest of this page, is just some pictures, and then so to try to help you out, these are some. Look, the most common type of prism that you're going to see is this guy here, the rectangular prism. and that's the easiest formula for volume. It's just length times width times height. That's the most common one. But if you see some of these other ones here, and look, and I guess I started off with a cylinder. What is the base of a cylinder? I know there's two of them, but what's on the base? What shape is the base? A circle, right? What's the formula for area of a circle that we already learned this year? Oh dear, formula for area of a circle. Haven't heard from anybody at home right now. And there's more of you at home than there are here. Pi r squared, yeah, that's where you see this pi r squared, but then times the height of the cylinder. If you see a triangular prism, I simplified this formula for you a little bit. It's the base and height of the triangle times the height of the prism, but then you divide by 2. If you see a trapezoidal prism, here's where you would have to add the bases, but you're not adding the two trapezoids, you're adding the bases of the trapezoid. We should have learned, again, you weren't with me back then, but in first semester you should have learned that the bases of a trapezoid are the one pair of parallel sides. That's what you sounded like. That's fine. Times the height of the trapezoid. This little h here is times the height of the trapezoid. The capital H is the height of the prism, and then divide by 2. But again, by far the most common types of prism is going to be the rectangular prism, and then you'll see some cylinders too. All right, we already talked about the top part. Here we go. Let's find the volume. So this is called an oblique cylinder. You see how it's kind of slanted, like the Leaning Tower of Pizza? So when you have a right cylinder, which would be like completely straight up, then the height of that cylinder would be the edge of the cylinder. But when it's something is oblique, right, like the height has to be the perpendicular distance between the two bases. So I'm not going to use the edge here. I'm going to use the one going straight up and down. In many cases, what they do to make this like a for your brain is you have to end up using Pythagorean theorem. Because if you won't need it here because they give you everything you need. But if you get that height, then we call a slant height, and then that segment there, what does that make? A right triangle. So be prepared for Pythagorean theorem at any point that could come in at you. But we have what we need here. So what was the formula for volume of a cylinder? Good. Pi r squared times the height. So we got the pi. What's the radius of that circle? It would be 9. I have not heard a thing from people at home. Pi r squared times the height, which is 14. Can you guys hear me at home? I know I can't see you, but we're going to give up on that. Yeah? Yeah, it's going to be 9 because this 18 is a diameter. So the radius is half of a diameter. And they want the answers in terms of pi and rounded to the nearest tenth. Okay, so in terms of pi, we get pi times 81 times 14. What's 81 times 14? $1134. Can you guys hear me from home? I'm not getting anything in my earpiece, so I don't know. Let me see. Let's pick a random person. Maylee, can you hear me?
Yes.
Oh, let's see. You guys are just being quiet.
I hear you, Coach.
Thanks, Kimon.
But it was lagging for a sec, though. I'm not gonna lie.
You were lying?
No, it just said you were sharing the screen for like 30 seconds, but it's back.
I don't know. Can you see my screen?
Yeah, I can.
Okay. I'm not sure what you're asking me, dude. All right, and then they do want to round it also. 3562.6. But wait, there's more. Yeah. Even though, like when you have a test, like your test and quizzes are going to be Google Forms, and you're probably not going to be asked for a unit unless it's a multiple choice question. There are units involved here. So in the past we talked about units of area, where when you got the unit of distance, what would you do to that unit of distance to turn it into an area? You put the little square on top. Take a while, guess what you're going to do with volume? Not squared. Yeah, so these would be inches cubed, cubic inches. Don't I have to what? Y square root, that's it. I finished volume, done. Pi r squared times the height. So the reason for this cube is because of the dimensions of measurement. So like here when I have a radius, okay, or a height, that is a one-dimensional measurement. Distance is a one dimension. If I wanted to see how far I was away from Miranda, I could measure it in one direction, in one dimension. Okay? If I then said, okay, well, hey, I want to see how much floor space there is, on the carpet here in the room. Now I'm adding a two-dimension, like a second dimension. And now there's not only a length, there's also a width. Okay, but now volume also adds a depth, three-dimensional measurement. That's where the little cube comes from. When you watch a movie in 3D, right? Movies are on a flat screen, but when you watch a 3D movie, a few years ago, that was all the rage. What happens? Well, what does it appear is happening to the image? It's coming at you. There's a third direction. Okay? You've never seen a 3D movie before? Damn, sucks. Should get on that, dude. Maybe not as much anymore. Yeah, I don't know. That kind of died out. I even had a 3D TV for a while, but then I don't even think they make those. Yeah. Yeah. Yeah, it would come with glasses. And then the hard part was finding the 3D movies, because you'd have to be able to find those on like TV or Netflix and stuff. But yeah, it's pretty good. Jurassic World in 3D. It's pretty neat. All right. Now here we're gonna do this as like an exploration. There's an answer I could just give you, but I want you to see it first. Let's say that we get the radius and the height of the cylinder from part A, which is the one that we just did, and we multiplied each one by 3. So now my height would be 14 times 3, which is 42, and the radius would be 9 times 3, which is 27, and describe how that affects the volume. Now, in order to do this, see, what we're doing here is comparing. We're describing an effect. Okay? So, now notice, what did I do to each of those one-dimensional measurements? What did I do to them? I just underlined it. What did I do to them? Huh? I multiplied, right? I multiplied. So if I want to backtrack and work backwards and see how that affected it, like, well, what's the opposite of multiplication? Division. So what I'm going to do is I'm going to get my original volume, which was 1134 pi, and I'll leave it with the pi's because the pi's are going to cancel out. My original volume was 1134 pi, and now I want to see what's going to happen with this second volume once I change these dimensions. Okay, just keep in mind that I multiplied it by 3. So my volume here is going to be pi r, which is now going to be 27 squared times the height, which is 42. 27 squared is 729. So pi 729 times 42. On what? I'm not worried about the pi. I'm gonna leave the pi. I don't need 729 times 42. Oh yeah, wait. I'm sorry. I typed it wrong. 729 times 42. You all right? 3618. Good. So this new volume, we'll call it volume sub 2. The volume of the second one is 30,618 pi. So if I wanted to see what type of effect changing those one-dimensional measurements did, since I multiplied and I want to work backwards, now I'm going to divide. So we would do this new volume. How would I see? Let's call this M for change. Would be 3618 pi divided by, was it 1134 pi? The pi's will cancel out, so it's just 3016 divided by 1134. That gives you a change of 27. So let's think about that. We got the single dimensional measurements and we multiplied them by 3. But then now volume, which is a 3-dimensional measurement, was really multiplied by 27. How do you think that 27 came about? How do you think that 27 came about? What can you do to 3 to get 27? You could multiply it. What do you think? What do you think really happened? It got cubed, 3 cubed. If you get single dimensional, so let's say instead of here, instead of multiplying it by 3, I multiplied it by 2. I multiplied each of them by 2. It's got to be both of them. So it's growing out proportionally. How do you think the volume would change? If I multiplied by 2, how much would the volume increase by? What's 2 cubed? Not 6. What's 2 times 2 times 2?
8.
Yeah, it'd be 8. It would be 8 times bigger. Let's say I got that radius and the height, and I multiplied it by 10. How would the volume change? How many times bigger would the volume be? I'm giving you easy numbers to do in your head. 10 cubed is? What's a 1 with 3 zeros?
1,000.
Yeah, it'd be 1,000 times bigger. So, still haven't heard anything from anybody at home. Where's Ferris? No, Ferris hasn't.
Ferris doesn't exist.
No, Ferris exists. With a haircut?
Oh, no. I'm about to braid it today.
You're going to braid it? If you have any questions, let me know. Hey, look at those cross sections. Cool, we were introduced to that the other day. Cavalieris Principle says that if two three-dimensional figures have the same height and have the same cross-sectional area at every level, then they have the same volume. Hey, look, we were just talking about CDs. A right prism and an oblique prism have the same base and same height, have the same volume. Oh, well, I guess I had already told you that. Cavalieris Principle also relates to cylinders. If the two stacks have the same number of CDs, they also have the same volume. Fax machine. All right, cylinder A and cylinder B are shown below. What is the volume of each cylinder? Well, yeah, I know they're going to be the same, but we want to know what it is. But here, I want to show you the difference. This first one is a right cylinder, okay? Because the edge and the base meet at 90 degrees. Cylinder B is an oblique cylinder, okay? But the height here, like you just can't use the edge as the height, but the height, because it's perpendicular, right, happens to be the same as this 12-meter height on the other cylinder. The diameters happen to both be 10, so Angel, what would the radius be? Yeah. So then, yes, they are the same. So what that means is that now, instead of having to find the volume of two cylinders, I only got to find it once, and they're going to be the same. Lana, is that confusion face? I see you, like, frustrated. Okay, so like, for instance, if this would have been 12 here, if I'm telling you that this edge here is 12, nah, they're not the same. But because that 12 is going straight down, just like this height is, that's why they're the same. So now, because I know they're the same due to that Cavalieris principle, I don't have to find two different volumes. I only got to find them once. They're both going to be the same. That doesn't make not making sense. Okay. Here, let's say I were to tell you that let's say that this 12 were here instead. Okay, and then I were to tell you that from this little corner here to there would be 5. Okay. So remember now, this is 12, this is 5, but I want to know what the height of that is. Well, I'd have to use Pythagorean theorem then to find that. Like, know the difference between a slant height and a regular height. For volume, you need the regular height. If we were doing surface area, more of the formulas for surface area tend to ask for slant height if you have an object that's slanted. But for volume, you just need the perpendicular height. Okay. Now the formula itself is going to be the same as the one that we already did for cylinder. We haven't done any prisms yet. So volume is just going to be pi. Kimon, what was the radius? Just had it on the board 30 seconds ago. Kimon is not home right now, but if you leave a message at the beep, he'll get back to you as soon as possible. Beep! Jason, what's the radius?
10.
10? No, 10 is not the radius. We just talked about what? It is a diameter. So what's the radius, Jason?
5.
Thanks, Ferris. And then the height is 12. So volume is pi times 25 times 12. I know that if I have 12 quarters, that means I have $3. So that's 300 pi. And then if I wanted to round, I know it doesn't say to round, but a lot of these problems do anyway. So 942.5. What would the unit be? Not meters squared, meters cubed, or cubic meters, yeah. Where are my car people in here? Caden, aren't you into cars?
Yes, sir.
Yeah. How do you measure engine size? What unit is used to measure engine size? You want to see how big an engine is? Well, cylinders tells you how many cylinders there are, but if you want to know how big the actual engine is, I guess it depends if it's a domestic car or if it's a foreign car, right? But if it's domestic, I believe it's cubic inches. You know how many cubic inches the engine is. Whereas if it's a foreign one, they use cc's. What do you think cc stands for?
Cubic centimeters.
Cubic centimeters. Sure. It's a measurement of volume. Find the volume of a cylinder with a base area of 121 pi and a height equal to twice the radius. Ooh. Ooh. All right. So volume is pi r squared times the height. Okay. But I also told you that just generally speaking, any prism or cylinder is the area of the base times the height, and they've already given this to you. So I already know what the base is. Like this pi r squared is accounting for the base. What am I missing? Huh? I'm missing the height. But I do know that the height is equal to 2 times the radius. So if I can figure out what the radius is, then I can plug that in. So the way I'm going to have to do that now is to use that pi r squared and make pi r squared equal to 121 pi. And we got to, how would I solve for r? If I want to get this R over here by itself, because that's what I need to, because then once I know the R, that'll give me the height. Divide by pi sounds good. Is that what you were going to say, Lana? So I'll let Lana finish it off then. Once I divide by pi and I get that R squared is equal to 121. How do I get the R by itself, Lana? How do I cancel out that square? How do I get rid of a square? You want to ask Angel for help? How do you cancel out a square? Divide it? No, you don't divide it. Thank you, Mo. Square root. Ferris, Muhammad says he's smarter than you. So now that I know that the radius is 11, I can plug that in up here. So my height becomes 2 times 11, which is 22. And now I can go find my volume. So the volume is the area of the base, which I already knew was 121 pi. I don't have to get fancy with that. It's 121 pi. They already told me that. Times the height, which I just found out was 22. If they want that rounded, volume is approximately 8363.0, no, 0.9. Sorry, 8362.9. If they wanted a unit, what would the unit be for that volume? I can't read on mine. Does it tell you? Is it centimeters? Okay, so then centimeters. Cubic centimeters. Cubic centimeters. Ooh, fun. All right. Prisms. So, prisms are going to abide by the same general formula of the area of the base times the perpendicular height. But if you maybe struggle with algebra but are good at memorization, I gave you some extra formulas on the first page. So if you could just identify the type of prism, it makes your life a little bit easier. Okay? What type of a prism is number one? Triangular prism, right? So I gave you a specific formula just for that, which it was the base of the triangle times the height of the triangle times the height of the prism, and then divided by 2. Is that correct? Because even I have to sometimes memorize it. I believe that's correct, though. Just double check for me. Yes, that's what okay. Okay. Well, this is even easier for this because the triangle is a right triangle. This triangular base is a right triangle. So the base and the height are just going to be the legs. So the volume would be 9 times 40. Remember, this is actually a really important thing. You have to understand this concept. The height of any prism or cylinder is the distance between the bases. How far away is one triangle from the other one? 48 centimeters. So times 48 and then divided by 2. Put that in your calculator. I'm getting 8640. Luckily there's no pi's here. What would the unit be? Yeah, cubic centimeters. What type of a prism do we have on number 2? Yeah, and these are the most common. They also should be the easiest because it's just length times width times height. So the volume here is just 10 times 12 times 8. 960? Alright. What would the unit be? Cubic centimeters. Alright. Ooh, how about number 3? It's the same exact thing. The only thing is this one is oblique. It's like shifted. But because they're giving you the perpendicular height, you don't even need to find it. Volume would just be, let me change the color. Volume would just be 1.5 times 4 times 3. Is that 18? I'm doing in my head 18. What would the unit be? Cubic feet. Okay. How about number 4? What type of prism do we have on number 4? Yeah, a trapezoidal. You're not going to see this a lot, but if you do, now correct me. Remember that the bases of a trapezoid are the sides that are parallel. So, like, make sure that you don't confuse the measurements. What are the two bases going to be there? 8 and 14. So the volume is going to be, I wrote that formula on the first page. You're going to add them. Then you're going to multiply it by the height of the trapezoid, not the height of the prism, but what's the height of that trapezoid, which is how far is it from those the two 10 centimeters. No, 10 is the height of the prism. These two bases of the trapezoid are 4 centimeters away. Then how far away are the two bases, the two trapezoids away from each other? That would be 10, and then divided by 2. So that's 22 times 4 times 10 divided by 2. Say it again. 22 times 4 times 10, right? So 11 times 4 times 10. Is it 440? And the unit there would be? Did I go 4,400? Let me see. 11 times 4 times 10. I'm getting 440. Well, in my head, to make the number smaller, like what I did was I knew that 22 divided by 2 is 11. So I could just then do 11 times 4 times 10. Okay. If we were to take a slice or a cross section of a prism that is parallel to the bases, we would get a shape that is congruent to each base. So the cross section of a rectangular prism is simply a rectangle. This is what I tried to kind of allow you to visualize last week on that activity that we did. You saw the different cross sections. If I did a vertical cross section to any prism, it would be, what do prisms have going around laterally? No. Prisms, what do they have going around laterally? Yeah, so you'd see rectangles, but if you do a horizontal cross section to any prism, you'd see what the bases are. So if it's like a pentagonal prism, you see a pentagon. If it's a triangular, you see a triangle. All right, I think that's where we're gonna stop today, because no, it's not about how much time we have left. It's because of what's coming. Oh, God, I hate this. We're already moving on to, pyramids and cones. All right, so here's what we'll do. Tomorrow, I'm actually going to review the test. I'm going to give you back the stuff from the test. I'll go ahead and I'm going to release the scores now. I don't think I've done that yet. So it'll go to your emails so you can see which ones you got right and wrong. Then I'm going to provide those of you that are here in person tomorrow a printout of the ones that were most frequently wrong, and that's the ones that we're going to go over. But it's going to be most of them. I don't think you're going to have any extra questions, but if you do, oh, Mr. Look, I had a question on this one, but you didn't go over it, I'd be happy to find it and go over it for you. That should take most of the period. If we have any time left at the end, then we'll continue with this. Okay. The way I have this week structured, it was supposed to be 4 days of lecturing, and then at the end, get started with the homework. But if we can finish all the lecturing early, then any more of that time would just be used to work on the weekly assignment. Any questions at home? All right, stay on really quick if you're at home because I want to make sure nobody showed up late. Yeah. Yeah.